Okay? All right. Now, exactly how much does that help us? Well, that's actually kind of an interesting question, and since we're doing computer science, uh, let's talk about that. So, uh, you know, well, we'll get into algorithm efficiency, which is it's big O notation in a little bit, in a couple weeks. But for the time being, we can look at this one specific example. So if n is our number that we're trying to define the number of divisors for, we can just try all of them, or we can take the square root of the number and figure out those. So what I did here was I had my computer do it, just had an applet, which you can Google yourself and probably find, which you plug in a number and it does it this way, does it with just trying all numbers, and then it tries all numbers with the square root, and it keeps track of how long it takes. So on my computer, it's going to be a little bit different for everybody's computer, but in particular on my computer, with 1,000, it took 0.011 seconds. Okay, not terribly long. With square root, it actually took a little bit longer, 0.014. Now, why is that? Well, actually, at the beginning here, this one we just can start trying. We just do 1, 2, 3, we go right through and check them all. Not really that big a deal. For the square root algorithm, we actually first have to find the square root, figure out what integer is closest to that, and then start trying the numbers of that. And actually, every time we find a divisor, we have to look for its partner. So there's actually a couple of little extra steps, which at the beginning, for smaller numbers, make the square root take just slightly longer. So what if we tried 1,000? 1,000 is a little bit bigger of a number. Well, it takes about double, which isn't bad considering this number, 10,000 is 10 times as big as 1,000, and the time only took a double. It only doubled. So let's do this one, 0.026. Again, square root is just slightly slower, but they're basically the same. Now let's jump up to 100,000. 100,000, we have n trials. Or if we just do all the numbers from 1 to 100,000, this actually takes 0.041 seconds. Again, very little amount of time, but it's not an unmeasurable amount of time. Moving on, though, we see finally here that the square root method, taking the square root, finally beats out the just trying all the numbers method. All right, so it wins. Okay, so let's skip ahead a little bit. We're gonna skip ahead. Instead of going from 100,000, we'll go right to 100 million. All right, so at 100 million, how long does it take to try 100 million numbers and see if they're all divisors? Well, it takes about 7.8 seconds. So that's a pretty big jump. What about the square root? That one only 0.092. Well, so this is a huge jump right here. From here to here, huge jump. Not so big a jump from here to here. All right, so maybe you can see where this is going. Well, let's finish up the square root trials. So if we do that is, what is that? That is a billion? 1,000 million, yeah, billion. So we try a billion, and a billion with the square root trials still takes less than 0.2 of a second. If we go up to 10 billion, still about a third of a second, a little less than a third of a second, a little more than a quarter of a second. All right, so let's go huge. Let's go up to 10 to the 18th. 10 to the 18th is an enormous number. So we look at 10 to the 18th. How long does it take the square root trials time, or square root to try, or to find all the factors of 10 to the 18th? Well, it takes about 4 minutes. Right now, 4 minutes when you're sitting there waiting for your computer to finish something is a long time. Kind of frustrating. But let's finish on the table here and see what happened if we just tried all of the numbers. From 1 to a billion, it takes us about 78 seconds. So what is that, a minute and 20 seconds-ish? All right. If we go up to, 10 billion, we have 1,949 seconds. That's a long time, especially compared to a third of a second here, right? And this is actually more than 3 minutes. So if we go on to 10 to the 18th, to actually determine 10 to the 18th for my computer today, it would take about 2,000 years. So you can see that at the beginning of the table, up here, it not so much of a difference between these two things. But as the numbers start getting big, the small difference in our algorithm made a huge, huge difference in the amount of time it takes to actually do